command line is a very useful tool. It's one of my favourites. It allows you to pull up external documents. It allows you to run other inspect programs. And one of the examples I'm going to show you today is how I can get it to load a photo so the operator knows how to load the part, for instance. And then at the end of the program, I want the machine to move back to the load position so the operator can put the part on the bed or take the old one off. So what I've done is I prepared a little program just to show you those two functions. So what I'm going to do is I'm going to run my program. Okay, and I've hit run, and straight away you can see on my screen that a picture has appeared. So this is my picture telling the operator how to load the part, the orientation, that sort of thing. The machine's not moved yet, but when I hit the close button, the machine's going to spring into life and start doing a measurement routine. So I'm going to just go ahead and do that. So you can see now the machine starts moving and it does my measurement routine, and then we're coming up to the second command line, which is just going to be put it in the load position. Okay, so that was nice and quick. So I'm now going to show you how I did that. And what I'm going to do is I'm going to load up another program, and this program hasn't got any command lines in it, but it has got a program. So this for you guys could be something, you might already have a program which already runs, and you're just going to add the command line in to modify it. Okay, so if you remember, the first thing that happens is we display a picture, and the picture stops the program until the operator clicks the cross to close that picture, and it goes into life. So how we did that was we did it at the top of our program. So we're going to move the cursor at the bottom to where we want to insert our picture. So I'm going to right click, insert here, and now you can see my cursor at the top. And now I'm going to insert my command line. So usually majority of the commands you need in Inspec are located in this panel here. Command line isn't. So to find command line, you need to go to your features menu. Let me show you. Just go to the top features, and we're going to insert a feature, and that's where we're going to find command line. So I'm going to click on that one. And now I'm going to look at the dialog box. I would insert a picture, so I can hit the browse button. And it's a simple case then for me of just selecting the picture I want to show. And then the other thing I need to do is click this wait for exit code. So the wait for exit code, that's the thing that pauses the program until the operator clicks close on the photo. And I'm going to click OK on that one. So there you go. You can see, looking at my features list now, I've got my command line. Okay, and I'm just going to move the cursor to the end now, right click, insert end. And then the other thing I wanted was to move to the load position. So again, that's a command line. So I'm going to go up to feature, go to insert, go to command line. And this time, I'm going to type in a command. Now, there are a few commands you can use, and I can't always remember what the commands are. So for that reason, I'm going to look at the help file. So to do that, you just press F1. And then if we go to search, if we search for executable file, it brings up this bit of information on the help file, but it's really useful because it's got the following commands which are supported. And you know, it has also got some extra information about it which you guys will be able to read and help you understand even more. So the one I want is this load position, because it's very easy to understand what it does. I'm just going to copy that one. Right click, copy. I go back to my dialog box, and I'm just going to paste. Just right click, paste. That's my command, as simple as that. And I'm going to click on OK. Now look at my program. I've got a command line here and a command line here, and I'm going to save that. And now what I can do is I can run it. It opens up, and I can close my picture. It goes to measure the part. And it goes to the load position. Okay, so just one more on the command line. On this top one here, I just want to highlight, we've got it opening up in Microsoft Paint. And the reason for that is because the exit code doesn't work in the default Windows photo viewer. So what happens is you get a little message on screen with a red cross on it just saying this hasn't quite worked. Then the program will carry on. So to get rid of that message, all you need to do is go to your Windows settings, to your default apps, and just change that. So I just go to settings, go to apps, go to default apps, and then it's just this photo viewer here. Change that to something like Paint. We know Paint works and it's on every Windows PC, so that'll work for you. Okay, and that is a couple of examples of where and how you can use command line. We've got some tools we can use which can change how the microview will behave when it comes across a feature which is maybe missing, or it can't see it, or it's got dirt in it, or it's out of tolerance. And that's what I'm going to show you now. So what I've got is, just looking at my screen, I've got a series of holes, and that's what my program's going to do. It's going to measure the holes, and currently in its current behavior, if I just run it, I've covered up some of the holes so it can't see it. It's just going to stop. There you go, it's going to stop, give me an error message, and if I've walked off to go do something else on another machine, it's not going to pick up the program until I come back and sort it out. So that's how it behaves sort of by default, and that might be the case for your machine. And you might have always wondered, is there a better way? So this is what we can do. We're going to go to something called Playback options and tools. And this is something we were using in the last webinar. We were using it to export results. So go back and check that one out if you haven't seen that webinar yet. But we want to go to the Failures tab. Here we've got 3 options, and you can see we've got tick boxes, and you can see, if they're ticked, they're turned on. And the top one here says pause program if a tool fails to measure. Well, that's the current behavior. What I'm going to do is I'm going to turn that off. So what it'll do is it'll just try and measure a feature. Oh no, I can't see it. And then it'll carry on to the next feature. We've also got pause the program if a feature is out of tolerance. We've got that turned off because we want to measure things, and sometimes things will be out of tolerance. And then we've got another option, pause program if a feature fails because of outlier rejection. So if you've got outlier rejection applied, it's taken some points out and it still fails, it will pause. Again, you can turn that on or off. Okay, so now that I've turned off pause program if a tool fails to measure, I'm just going to save that. I'm going to run it now, and you can see the behavioral difference. So it's all fine at the moment. Can't see these, look, and it's just carrying on. It's not pausing, it's not stopping. So if I've got a nice long program, it will try and measure these bits, go on to the next section, and then we can sort it out at the end. Okay, so program's ran now, and I need to check to make sure it's measured all my features. So we've got the summary and the log tab up here. It's the log I need to look at. I need to look at these 3 icons here. So we've got a green tick, which is going to show me everything that's measured successfully. And we've got a cross for things that are out of tolerance. I haven't got any tolerances in my program, so that's why nothing's showing. And then finally, we've got a failed to measure. So I can turn that on, and it shows me what's not measured. And if you like, I can get rid of these green ticks. I'm happy with them. So turn the red cross off. I'm only interested in what's failed to measure. And what I can do is I can click on circle 9, for instance, look at my schematic view, and it shows me where it is. I can just go down, look at it, and it shows me a picture of the camera window as well. So if I had dirt in my hole, I would see that, and I'd know that I need to clean the part out. But for me, looking at my part, it simply looks like they haven't put this hole in. They've forgotten to machine it in. So I can go, I can just confirm by looking at the part, and I can see they've forgotten that. So that can be a very useful feature. you don't need to make the machine stop if you've got a long program just because you can't see it and you've got a load of other stuff to check, and then you avoid your machine sitting idle. Real useful feature. Suggest you go and try it. Again, that's just tools, playback options, and it's the failures tab, and you've got those 3 tick boxes there. So we're just highlighting this feature because we had this question based on following on from one of the other webinars. So hopefully you find that useful. One of the advantages of the Excel machine we've got here is we've got a large working space, so we can fit many parts onto the glass bed. Could be the same with your Vertex. You might have small parts, and you might want to be able to measure more than one part at a time. So that's what I'm going to show you here. So I've got 4 parts here. Here they are, just at the front. And what I'm going to do is show you how we can measure them without using a fixture. So we simply put them onto the bed of the Excel, and then we can program it in such a way that it will find it, and it will always run no matter where we put it on the bed. So that's what I'm going to do now. I'm going to do it in front of you guys. I'm going to get my 4 parts. I'm just going to put them on the machine somewhere. Now I'm just using this small corner of the Excel here, but I could use anywhere up there. It's the same principle, doesn't really matter. So look, I've just placed my 4 parts onto the machine, and what I'm going to do now is just show you the program running, and then talk you through how we did it, and then look at a different way of doing it. So let me just run the program first of all. Okay, so the way it works is we need to give the operator, we need to tell the operator to tell the machine where the parts are, give it a start. So for that, I'm just using a manual point, and I have to find the first part and say where the first manual point is, which is going to be this corner here for all 4 parts. So that's part number 1. And now it's asking me to find the second part, which I'll just use the one below it. And that's the second part. Find the third part. Oops, there it is. And then finally part number 4. So my example is just using 4 parts, but there's nothing to stop you using more than this. It depends how many you can fit on your machine. That's quite an angle on that one. And there you go, there's that one. And now I'm just going to hit play, and it's going to go and measure the 4 parts for me. So this program's just measuring 4 holes, just keep it nice and simple. But the principle is how it finds them. So there you can see it's found the next part, and it'll measure it as well. So this can be really useful. You can combine this with what we showed you earlier with the playback options. So if it doesn't find the part, let's just ignore it and go on to the next part. That could be useful if I've got a program for 10 parts, but I only want to check 5. It'll just ignore the bits when it doesn't find a part for it. Okay, so that's found the last part now, and you see it's ran all the other ones. I could take them off and put them somewhere else in the bed, and it would still run. So that has run now. So now I'm going to talk you through how we did it. So what I'm going to start by doing is I'm going to use this in the software I got. I'm going to delete those 4 parts to begin with. I'll just keep the 1. And I'm just going to show you, we've got these start points. That's what the manual points are, the operator took. And then what we've done is we've saved these systems. So I created an XY for start 1, XY for start 2, XY start 3, and XY start 4. And then what I've done is I've stored the system. So to do that, I've just right-clicked, go to store, and saved it as part 3, part 1, part 2, and part 4. Okay, so once I've done that and I've programmed my 1 part, we're going to do it's called translate, and it's just going to copy and paste essentially. So what I'm going to do is I'm going to select the first system, and that's all my program. I'm going to right click, and I'm going to go to translate. Okay, so I've got 4 parts, so I'm going to have 3 copies. So that's what I'm going to do. Click OK. Okay, now remember we stored the systems for these start points. So it's all these here. This is the key to it. What we're going to do now is we're going to go down. There's my end of my program. And if you look here, this system, it recalls part 1. Well, I'm going to change that. So I just press delete. I'm going to hit the recall icon, which is this curly arrow at the bottom. And I'm going to select part 2. And when I do that, you'll notice that the graphic appears about here, because that's where the point is, where the coordinate system is. So if you watch this, can you see that? That appeared there. So I just do that again for all my parts. So go down to that one. It's recalling part 1, but I need to recall part 3. So delete that one, recall button. And because I stored it, I can get it back. There it is. And then I go back down to the last one, change it from part 1 to part 2. Sorry, part 4. There's part 4. And now you can see in my schematic view, which is going to be this area here, I've got my 4 parts, and it's arranged as they are on the bed, so that means that I've recalled the correct system. And from then on, I can just press play, and it will go around and measure it. So the key thing to remember is, first of all, we're storing the system, and second of all, we're recalling the system. So what that's done is saved a lot of time and effort in programming it. We just program the part once, just copy, paste it, change the system, and then it should be good to run. Okay, there is another way of doing it, and I'm going to show you that in a second. Okay, so we've shown you a method of measuring many parts on the Excel or Vertex, and we simply put it onto the bed, and we had to tell the machine where these parts were using a manual point. So there is an alternative way to this, which basically makes it a little bit faster, a little bit quicker when you run the program. And what we're going to do is we're going to use a fixture now. So I've got the same 4 parts, but I've got it in a fixture, and it's going to be a little bit quicker because I haven't got to manually click and say where each point is, because I can come off the fixture. I know each part is going to be in a relative position. So what I'm going to show you now is with the software, I've got a part program. I'm up to the point where I programmed 1 part, and now I'm going to program the remaining 3 parts. So in the software, what I'm going to do is I'm going to highlight the amount of code that makes up 1 part, and then I'm going to right click and go to translate, exactly the same as what I did last time, but this time I'm going to state what the distance is between them in the fixture. So in my case, these parts are all 80mm apart. So I can click OK. And you can see there I've just got the one part. So it works for 1, it'll work for more. So I can just do the same thing again, translate, and this time type in 80 again. And I could say I've got 3, 4, I've got 10, however many parts it is. Just to show you one more time, I'm going to say I've got 2 to make up 4. And there you can see I've got my 4 parts. They go black because they're not measured yet. And what I can do is I can just right click and remeasure just to test that. So you can see it goes round, it's just going to measure my 4 holes that make it a part, and it just moves to the next one. And it's able to do that because of the 80mm offset I put in there. So you can see this is much, much faster than having to take manual points. It's a lot simpler. Because the way I've programmed it, I've come off the fixture. So if I wanted to, I could move the fixture somewhere else. I might take the fixture off at the end of the day, put it on the table, and then all those parts are going to be found because it comes off the fixture. So it's nice and simple. So fixtures are a great way of measuring many parts on one machine. We can help out with fixture designs. It's something we do here at Sempra. We work with a MicroView. So, if you've got any challenging parts that you might need to benefit from a fixture, we've able to do it with automated parts before. We've got lots of experience working with the MicroView and fixtures. So please get in touch and challenge us.